Hello and welcome back to part 2 in our creating a Linux distro series. So in this part we're going to set up Grub, and this is pretty much what's going to load up our operating system, and we're going to add a nice UI so that it actually looks nice. Alright, let's get started. The first thing we're going to do is we're going to make a script to create our ISO. So we're going to call this build ISO.sh. So the first thing we're going to do is we're going to create a file which is going to be our ISO file. So this is going to be a file which is 920 megabytes, and it's just going to be zeros. Then we're going to set up partitions on this, which is pretty much going to tell the operating system the layout of the drive. Then we're going to set up a file system. This is going to contain information about what directories and files, just like how this folder we're in right now has a file system. And once we have the file system, we're going to copy on some files and then add our theme to Grub. The first thing we're going to do is create that empty file. So we're going to do a block copy. So dd is a command for doing a block copy, and it takes in an input file, which will be dev0, which is a file of just zeros, and an output file, which will be disk.image. And we want to put this inside of a folder just for some organization. So we'll make a directory ISO build ISO. Okay, so we're going to have an input file of zeros, an output file, and then we're going to put the block size as 1 megabyte. And what this is going to do is this is going to copy 1 megabyte at a time from the /dev/0 file. And then we're going to do a quantity of 928. So our complete file is going to be 928 megabytes. Okay. So we want to run this, and in the past what we were doing is we were doing bash build ISO. So we can do this. However, another way that we can do this is we can do tasks. So if we go and configure task, so I press Control-Shift-P, and we'll go down to, or you can type in tasks, configure tasks, create a new JSON from template, ms build, and we have a tasks file. And we're going to get an extension too. So this is optional. However, I have the task Explorer extension. There's 2 or 3 different extensions, and there might actually be more, which pretty much add a new panel that you can run tasks in. We're going to refresh this, and we have a build task, which matches up with this label here. So we're going to rename this to build ISO. It'll be a shell command. The command is going to be bash build iso.sh. It'll take in no arguments. Group build. And this is for ms build, which is something related to .NET code. So that's not something we need. Okay. Let's do this again. Let's delete our where is it? Build ISO. And let's refresh and test our task. Okay, so it ran the script, and as you can see, it's done the same exact thing. Okay, so let's add this to git ignore. Okay, so now we have an empty file. Let's take a look at this file, and we're going to look as we go through this video at how the file changes. So we'll run ghex on build ISO disk.image. As you can see, this file, and this is the contents, and then this is a text representation of the contents. So if there was any text in these ones and zeros, it would show here. As you can see, the contents are literally all zeros. Okay, so one other thing that we can do is we can do hex dump. And this will give us the zeros, and then anytime there's repeating spaces or repeating zeros, it will pretty much remove that and give us a very short command line output. So this is useful for if there's a lot of zeros and you don't want to have to scroll through a very large file. whereas the other one is good for seeing like, oh, is this at the start or is this at the end? All right, so now we're going to partition the file. So let me open up my notes. And there we go. So we're going to run gdisk, disk.image, and let's actually cd into build ISO. And this is a tool for creating partitions, and it's a command line tool. So the only way to use this is by manually typing stuff in. So there's a ton of different commands that you can do. So we're going to run help. And as you can see, there's a lot of different options. And then if we typed in ls, we can see all the different file systems. So these are types of partitions. So every partition is going to have a type. It's going to have a start point. It's going to have an end point. I think that's about everything. If you plug a USB drive into your computer, you're plugging one device into your computer. The whole idea behind partitions is you can split up a device into different sections. So you could take one flash drive and you could split it up into two different devices, whereas the first half of your flash drive is one device and the second half of your flash drive is another device. So you'd have one flash drive plugged into your computer, and on Windows you'd have like a D drive and an E drive just from that one flash drive. So it'd almost be like you were plugging in two flash drives. Okay, so what we're doing is we're literally creating a table. The operating system is going to read the table, and then it's going to say, okay, this is the first partition. So there's a bunch of data here, which is our first device. And then there's the second partition. There's a bunch of data here, which is another device. We'll type in O, and that deletes all the partitions and creates a protective MBR, which is kind of like an old way of doing things. And then we'll confirm that. And then we'll make our first partition with new. So new partition will be number 1. The first sector, we're going to leave it at 2048. And I think the reason for this is the partition table probably goes at the start and takes up the first 248 bytes. So next, we can either type in the offset of where this ends, or we can just use the plus, which is much easier. So we're going to make this 1 megabyte, and then we're going to put the code as EF02. And this is a BIOS boot partition, which is used for, it's how operating systems used to boot. So this will give us support for older motherboards, probably those over 10 years old. So we're going to make another one, 2, and we're going to start this at right here. And this is just the end of the last partition. So this +1 ends right here at 4096. Okay, so we're going to do plus, at least I think it does. I'm not exactly a partitioning expert. But I promise you, if you type this all in, you will get a working operating system. So, anyways, that was actually a mistake, so we weren't supposed to do that. So, we'll just do +48 again, and we'll do EF00. So I'm going to pause the video. Now we're making partition number 2. So we'll do N2 4096 plus 48M and EF00. Now we'll do partition 3. So we'll go N3 1. We'll just accept this, and we'll accept the end. So this default value is just going to be the end of our 928 megabytes. So this is probably about 928 megabytes. So we'll press enter. 8300, which is a Linux file system. And there we go. So we'll list out our partition table, and yours should look something like this. And we'll press W to write it, and yes to confirm. And this is fine because we called gdisk on disk.image. So if you were using this on your computer, then don't press yes. So make sure you're running this on gdisk on disk.image instead of your operating system. All right, perfect. And it says, oh, it will be there after the next reboot, but it's fine because this is on disk.image. Okay, perfect. So this works great. And what we could do is we could take this disk.image as our starting point, and we could just copy from this each time we want to make changes, and then we can start from a clean slate. But what we're going to do is we're going to make a script which is going to do what we just did. And to do that, we can use echo-e. So this allows us to put something into another command. So we did test, 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 and we did the pipe symbol, and we did grep into test. So this command would go into the grep command. And grep will highlight the EST for us. So we can do the same thing, and then we can pass it into gdisk. So we're going to call the disk.image, and before that we're going to go echo e, and we'll pipe this in. So the first thing we'd want to do is O. So if you remember, we did gdisk.image, and we did O, which deleted all the partitions. Let me make sure I am on disk.image. And then we can go yes, new 1, and then we'll just put in like 2048, etc. So let's put this in. And it doesn't let us keep typing. However, as you can see, it has run these commands. So this is the output that you'd get if you had typed in all this stuff yourself. So what I did is I just went through and I wrote out what I typed in into this echo E. And I don't know why there's 2 spaces here. There needs to be 2 spaces. And this will be in the notes in the description or either on the GitHub. There should be documentation too that you can follow along with, and you can just paste this in. And this is pretty much just typing in all of those values that were already in there. Okay, so now we've got our new disk image. One other thing we're going to do is we're going to delete and recreate this disk image every time. So what might happen is you might write to this, and then you write to this, and you make a change, and then it never gets regenerated. So let's delete that really quick. We're going to take this disk.image, and then we're going to put it in an if block. So you don't need to remember this. I don't remember this, so I just pasted it in. This space right here and here at the end, these are very important. And this F says file. So it checks if this file exists, then it will print this message out and it will delete the file. So let's comment out our new creation option and let's run this. So as you can see, it's deleted our file. So now we're going to have a new fresh file each time we run this. Okay, so now that we've partitioned it, let's take a look with ghex. And now there's actually some data. So as you can see, it says UEFI part. And if we scroll down to the very bottom, we have, I'm not sure if this is a duplicate, but some additional data here. So maybe that's a backup. And we can do hex dump -c. And we can see that there's a little bit more, and this is the location of these different parts. So maybe this is all the start because these are low numbers, and then this E or 39FFB is probably near the end. Now what we're going to do is we're going to set up something called a loop device. So loop devices are pretty much a way of writing to files. So each of these partitions is going to pretty much turn into a flash drive in the eyes of Linux. So each loop device is going to be like each chunk is turning into its own flash drive that's in our computer. And then once it's a flash drive, we're going to create a file system on it. So let me press enter, and I'm going to check, do I have any loop devices? Type in loop setup dash, maybe no dash and ls. And let's type in help. So we can use dash A to list all the used devices, and it looks like that's what we need. So we'll do loop setup dash A, and we have no loop devices. So if we needed to, I think we can do like loop setup remove or something like that in order to get rid of any loop devices. Okay, I just double checked, and it would be loop setup dash D. We're gonna make our first loop device, sudo loop setup dev loop 0 disk.image, and we're gonna try without the sudo and see if that works. And that does not work. Okay, so now if we list all our loop setups, as you can see, we now have our first device, and it is attached to this disk.image. For the next two, we're going to pass in an offset. So our next device is going to start 4096 into the file, which is also where we started our second partition, and it's going to end right here, which is one before this. We've got both of our loop setups, and the next thing we're going to do is we're going to mount. So we'll go, and first we'll check, do we have any mounts? Type in mount, and we'll filter this out with /mount/, and we have nothing mounted. Okay, so we've got no mounts, so we're going to make a directory on our computer. And both of these directories are going to be spots on our computer, which are then going to map onto these devices. So let's say we just ran mount right now. We can run mount dev loop 1 /mount/EFI, and we can run mount dev loop 2 to mount drive, and let's run this. And then let's run this one, and let's do it as a super user. And it says can't read super block, and pretty much the reason for this is there's no file system. So if we were to open up hex dump and we were to go to 2048, or in this case we're mounting loop 1, so if we went to 4096 and looked at what was there, we're just going to see zeros all the way from there to 48 megabytes later. So what we want to do is we want to make a file system so that when we mount and it starts here and ends here, it doesn't just read a bunch of zeros, it reads a directory structure. And that directory structure is going to say the names of files, it's going to say folders, their permissions, those kinds of things. And if it sees, oh, there's this directory information, this table of all the directories here, then it's going to realize that there's actually a file system, and it, even if there's no files in it, it still knows what it is and what it's looking at. Okay, so we're going to run mkdosfs -f32 /dev/loop1, and this will make a FAT32 file system, which is pretty much a Windows-like file system. So we'll run these. Unable to discover the size, so I don't know if that's an issue. However, if we mount and it works, so I actually don't think I ran loop setup. Okay, so these are actually set up. So we'll do setup. So we do have our loop devices. So this should work. And it looks like it did work. And this one did work. And our mounting works. So I'm not exactly sure what happened. However, now we actually have these file systems. So we can run hex dump -c disk.image again. And we have hopefully some more stuff. So we've got this fat, we've got this fat32, and we've got some stuff here. So now I've got our file system. So just one more metaphor is, let's say we type in ls mount /efi or /mount. So if we put anything in this EFI folder, like if we copied something into mount EFI, then this is mounted to this device, and this device is a representation, it's a chunk of this file. So this mount EFI would write to this loop device, and this loop device 1 is a file is from 4096 all the way to here, which is 48 megabytes. So we have 48 megabytes of space in this. We have a lot more space. The rest, almost 900, well, 800 some megabytes for the rest of it. This is the hard part, and we've got a lot of it done. Now all we need to do is install Grub, which, to be fair, could also be considered a hard part. However, just from like an understanding things, this is a lot harder. So we're gonna make a new file, and we're gonna call this build grub. Okay, and we're gonna go back one step before we do our build grub.sh. We're going to remount every time. So if, let's say we run this script right now, we get some errors. It's already mounted. So we'll unmount, and first you have to unmount, and then once you unmount, then you can remove the loop devices. So we'll unmount, and then we'll delete the loop device for loop 1. So we'll delete the loop devices for loop 0, 1, and 2. Okay, so let's rerun our script, and let's make sure that everything's working. Okay, I think this needs to be /dev/loop0. And we actually did this after loop setup. And we actually did this after loop setup, so this needs to go before. And let's try again. As you can see, there are no errors. The final thing we're going to do is run chmod 777 on disk.image. And this will give us permission for any user to use the disk file, the disk.image file. Okay, now on to build grub. So building grub is just like the other processes. So I'm just going to copy and paste in the code. It'll check if the directory exists in the download cache, and this should be downloads. And then it will download the file and unzip it. Once we've done this, we're going to copy out of it. So I'm using 2.14. You might want to use a more recent version. And this is going to be copied into a new folder. And let's test this out. So we'll actually add a task too. Actually, we'll do the task in just a sec. Okay, so I don't see this compile grub folder. So let's ls grep file grub. Let's do ls-r for recursive. And that's not what we want. So it looks like we were still in downloads though when we made compile grub. So let's actually go cd ... And now we have our compile grub folder. So pretty simple. You're going to need to install a few different things. I'm going to paste them in. So you'll need to install these in order to build grub. And we're going to look inside of here. And we did not copy correctly. So if we go into downloads, so we CD'd into downloads, we downloaded it. We should be able to copy. Oh, we already CD'd up. So let's do downloads / and there we go. So let's delete this. And there we go. So what we could do is we could do, now always be careful doing rm.rf, because if we did this, you'd wipe your system. So we'll just do compile grub, and again, be very careful. And let's run this before we do a copy. And that removes our compile grub. So again, be very careful. There's been some bugs where people have wiped their systems, messing around with relative paths instead of an absolute path, and using this rm.rf. Okay, so let's rerun this and get our grub back. And there we go. And now we're going to cd in grub. We'll compile grub. And we're going to configure it. So we'll run this configure command. And we're not going to use sudo because then all of our files are going to be hard to use in the future. And this creates a configuration. Now, normally what we'd run after this is make with this nproc. I've added this awk equals gawk, and that's going to fix a bug and make it easier in order to get this compiling. So using this awk equals gawk is a workaround that I needed because I'm using the latest version of Grub. This is just like before, we're making, and then after that, this will be in the description somewhere. It's going to make a file inside of this compile grub directory for a program called grub install. So we're going to target this EFI target. This is where it's going to go, which is that mount point from earlier in the other build ISO file. And some modules is what's going to be included in our grub. So we'll run this grub install. And failed to make directory. So let's try it as sudo. And when we run it as sudo, it works. Okay, so that's literally it for installing Grub. Now, if we look at where Grub installed, we can do ls mount drive boot /grub. And actually, this should be /mount /EFI. And so as you can see, it copied right into this folder. And this works great if your computer knows to look for this, but because we're putting this on a USB, it's not, usually what happens is some information gets put in the motherboard and then it knows to look here. So our computer's not going to know to look here, so we're going to need to use the default fallback path. So we're going to copy this in, which is going to make a new directory very close to it, and we'll copy it to the fallback path. So when our computer boots up, it will check here, and then it will find Grub. So now I've got this. We've got pretty much everything on our disk.image. The only thing left really is to put on a grub config, which is going to tell Grub where our kernel is. So we'll make that grub.cfg. And for now, you can copy and paste this in from wherever you've been copy and pasting from. And then we're going to copy a few different files here. So we're going to copy grub config, which is, so we just ran grub install, so we're in this grub directory. So let's actually go up a directory, dot slash, so we're no longer in this grub compilation. And we'll copy the BZ image from last video, the init ramfs, and we'll copy this grub config. So this grub config is just going to say boot BZ image. BZ image is going into boot, the boot folder, and init ramfs is going to be in the boot folder. And it's going to load up a font and create a grub entry called myOS. So let's run these. And we need to go up. And hopefully, let's see. What folder are we actually going to be in right here? So when we run starting grub build, I don't actually think we're going to be in compile grub. So I think we need to go cd compile grub. And we're going to put in a make clean here so that if we haven't cleared this out, it will still be here. Okay, so we'll rerun our build grub script, and let's actually create a task for this. So this is pretty much a list in JSON, anything in between these square brackets. So we'll make a new entry. And we'll put in build grub. And let's see if there's any errors. Cannot create directory compile grub, it exists. So let's fix that. It looks like we've made some issues with where we are in the path. So let's work through this and go cd. Then if we cd ... we're back to where we started. We make this directory. We cd up again, so this probably shouldn't be here. And then we cd into compile grub, and then we cd up twice. So let's ls. So we should only be cding up once. And we're back to where we started. And we can copy this BZ image and grub config. So let's try that. All right, so it finished with no errors, and now let's test it. All right, so let's go to build ISO, and let's test it out. Now, sometimes it takes time for everything to copy on with these loop devices, so sometimes it'll error out, and if you wait a minute and then retry it, or retry it 2 or 3 times, then it will work. So let's see, and let's start up our Linux and see what happens. All right, it's been about a minute or 2, and as you can see, nothing's happened, and this probably means that we have a uncompressed kernel. So the kernel is just taking up a ton of space, and it's not running compressed, which causes this issue. So what we're going to do is we're going to close out of this, And you might also need to install OVMF also in order to get this to work. All right, so if we look right here inside of our build kernel script, as you can see, we make the default config and we don't necessarily copy in any other config. So we're going to want to take a config which has pretty much the compression option turned on. So I'm going to put some information in the description. We'll probably look at this in the next video,